For the second part, we want to show that when you have a function written as the composition or the addition of two other functions, when you take the derivative, you take the derivatives of the individual functions and then add them together. So how do we do that? Well, no one's surprised, the definition. So we have that the f prime of x is this limit from over here, so the limit as h tends to 0 of f of x plus h minus f of x divided by h, and that is going to be equal to, well, f is just g plus l, so we get the limit as h tends to 0, this might be a tight squeeze, of g plus l of x plus h minus g plus l of x divided by h. That's just going to be equal to the limit as h tends to 0 of g of x plus h plus l of x plus h, because we have g plus l in a bracket here, so we can actually expand over the brackets, minus, and then we've got g plus l of x, so that's g of x plus l of x. And that is still all over h. We can keep going. We say that that's equal to the limit as h tends to 0 of, well, okay, here we've got to be a little bit careful. We've got to make sure we get everything in the right place. So we get g of x plus h, and then I'm going to use one of these minus things in here. I'm going to use the minus g, so minus g of x, and then that's all over h, and then I'm going to add l of x plus h, and then minus l of x, and that's all over h as well. It can also be distributed, so we get that that's equal to the limit as h tends to 0 of g of x plus h minus g of x over h, and then plus the limit also as h tends to 0 of l of x plus h minus l of x, and that's going to be over h as well. And because these are the definitions for the derivative of g and the derivative of l, we do get the desired result as I've written earlier. So great, that's a couple of basic trivial results in differentiation. I hope that helps.